Hi class, today we're going to look at section 8.5 and we're going to learn how to graph quadratic inequalities. Now I broke this lesson down into two videos. This video will focus on when we're given vertex form, and the second video will focus on what happens if we're given standard form, which will be good because it reviews a concept we learned earlier this year. So you can see that our objective today is I can graph a quadratic inequality. And again, the addition to that would be both given vertex form and standard form. Now the good news is in section 1 we learned how to graph linear inequalities. And you will see that actually our three-step process is the exact same except for we need to be able to graph a parabola first instead of a line. And then step 2 we will decide if it's solid or dotted. And step 3 we will figure out the shading using the test point. So again, on this first page, we are given vertex form. So we do have to review that if we're given 2 times x minus 3 squared minus 4, we have to review where to find the vertex, which is also the same idea as how it shifts. So again, the x minus 3 in parentheses means that it shifts the vertex that was at 0, 0, 3 to the right, so it would be at positive 3. And then this minus 4 on the end tells me that I would shift it down 4. Which means the vertex goes down 4. So when graphing a parabola, the first thing we have to do is plot the vertex, which means I go over 3, down 4 for this example. And now this next part is the part I talked about in class that we didn't necessarily get a great grasp on the first time we learned how to graph quadratics. So I do really want you to make sure throughout this chapter you focus on remembering this idea. Okay? We did learn that when we graph quadratics or parabolas, we need 5 points. One is the vertex. But then these next 2 steps help us graph the width exactly. So we said from the vertex, we're going to go over 1 up a times 1 squared. Okay, so this is where we're going to go. A is 2 in this example. So because again, the a is the number attached to parentheses. So I go 2 times 1 squared. Which is 2 times 1, which is 2. So again, what this means is from the vertex, I'm going to go over 1, up 2, in both directions. Now, it's a good time to talk about how this is different than absolute value. Remember, with absolute value, this 2 actually was like the slope, so we just kept going up 2 over 1, up 2 over 1. The problem is because it's a parabola, it's not going to change like that. You have to actually account for the fact that it's squared. So that's why to find the next points, we are going to go over 2 from the vertex and then up a over 2 squared. So again, the a is still 2, the 2 squared, 2 times 4 is 8. So again, back from the vertex, I go over 2, up 8. And then you'll see that this is not the v, it's not a constant rate of change like it was in the absolute value, which is why it's a curve. Okay? So now, when we look at this, we graph the boundary of the parabola. Remember, step 1 is just the points for the boundary. Okay, just like on the line. Step 2 is we decide if it's a solid or dotted parabola. Remember, in order to figure that out, we look at the symbol. Because it is less than or greater than or equal to, it's going to be solid. If it was just less than or greater than, like this, it would have been dotted. So I'm going to draw a solid curve. And that goes through the vertex, goes up in both directions. And then finally, step 3 is the shading. Okay, you're either going to shade inside the parabola right here, or everything outside around the parabola. Okay, and again, we get to use the test point. Again, unless the parabola goes right through the point 0, 0, 0, 0 is going to be my best test point. So I'm going to scroll to the bottom and I'll come back up. So we already said it's solid, and we can test 0, 0. Now, again, what that means is I take my inequality, which is y should be less than or equal to 2 times x minus 3 squared minus 4. And I'm going to plug in 0 for the y. And 0 for the x. And now we have to be better at algebra than we were in the other, because it's a little more complex. Oops, sorry about that. So I do my order of operations. I do 2 times 0 minus 3 is negative 3. squared minus 4, so I simplify inside parentheses first. Next, I deal with my exponent. Negative 3 squared is negative 3 times negative 3, which is positive 9. Bring everything else down. 2 times 9, because now I'm at multiplication. 18 minus 4. I get that 0 should be less than 14. And I ask myself, is 0 less than 14? And yes, it is, which means it's true. Okay, and again, I usually use yes or no instead of true or false. So yes, it is, which means, now that I go back to the graph, this point is in fact a solution to this problem, which means that everything on that side, which actually means everything on the outside of the parabola, is a solution. So I shade in all of that. And that is the process we use. Okay, so again, it's the same 3 steps as graphing a linear inequality, but the big difference is we have to be able to graph a parabola now. And the second big difference is that we have to understand that when we use that test point, it's not one side of the line or the other. It's either inside the parabola or outside. Okay. So the next one, my vertex, again, because it's x plus 4, it'd be a minus 4, and the minus 6 is down 6. So my first point, I go negative 4 and negative 6 and plot a point. And then from the vertex, again, I go over 1. I like to think about it both directions, and up 1 times a times 1 squared. My a in this case is 1/2, so I do 1/2 times 1 squared, which is 1/2. So while it's kind of odd because the boxes are small, I'm literally going to go over 1, up 1/2 of a box, over 1, up 1/2 of a box the other way. And then for my 4th and 5th point, I always go over 2 from the vertex, up a times 2 squared. So I go 1/2 times 2 squared, which is 1/2 times 4. So since a is 1/2, go up 1/2 here. Since a is 1/2, go up 2. So from the vertex back to the beginning, I go over 2, up 2. So you can see that it's getting wider. Over 2, up 2. So that's step 1. Step 2, I ask myself, is it solid or dotted? I go back and I see that my symbol is less than or equal to, so it's going to be solid. So once again, I draw my parabola through those points. And then it appears I'm not going through 0, 0. So I can use the test point 0, 0. I take my 1/2 times x plus 4 squared minus 6 and decide if it's less than or equal to y. I have to go through my algebra. Plug in 0 for x and y, and then simplify the left-hand side in this case. 0 plus 4 is 4. 1/2, 4 squared is 16. Half of 16 is 8. Is 2 less than or equal to 0 is what I get to. So I ask myself, is 2 less than or equal to 0? No, it is not. Or you could say false, but again, I usually use yes or no. Which means that in this example, this point at 0, 0 is not a solution to the problem. As a result, I need to shade inside of the parabola because that is the part of shading that does not include that point. Okay, why don't you pause this quick and try the third one on your own, and then turn it back on to check your answer. Okay, this one was a little different. It didn't have a number on the end, so you should have thought about it as plus 0. So my vertex goes 4 to the right, so positive 4, and then up 0. So I go 1, 2, 3, 4, up 0. It's right there. My a value, you can see I'm telling you is negative 1, and remember that's this number right here. If there's no number, it's like putting a 1 in front. So I do a negative 1 times 1 squared first, and I get negative 1 times 1 is negative 1. So down, and I probably wouldn't put that word there, I just say go over 1, down 1, or negative 1. So from this point, I'm going to go right 1, down 1, and left 1, down 1. I do both those points at the same time. Then I have to do negative 1 times 2 squared. Negative 1 times 4 is negative 4. So from the vertex, I go over 2, down 1, 2, 3, 4, over 2, down 4. So I've got my 5 points that create the boundary. Then I ask myself solid or dotted. Now this time it's just y is less than. So because of that, I'm going to draw a dotted parabola. Okay, so dashed is probably a better word, but I draw a dotted parabola through there. And finally, I do my test point. I can see that it does not go through 0, 0. So I'm able to do my algebra with that. Again, I start with the original problem. I'm going to put the -1 there. Minus 4 squared, technically plus 0. Y is 0, less x is 0, and then I simplify. -1, 0 minus 4 is -4 squared. Keep that -1 in front. -4 squared is -4 times -4, so positive 16. And then -1 times a positive 16 is -16. So this one would have a lot of mistakes made because of the negative in front and the negative inside parentheses. So you should end up with a -16. I asked myself, is 0 less than -16? No, it's not. It's bigger than it, so it's false. Which means that, again, I do not shade over 0, 0, which means I do not shade on the outside of the parabola, but instead I shade inside of the parabola. So again, this is a great review of how we graph parabolas given vertex form. So what your 3 graphs should look like, and I'm going to end this video here, and then you should come back and watch the second video for this lesson, which is what if you're given standard form. Thank you.